Okay, looks like it's bang on one, so I'm going to kick off with a presentation. This webinar is just going to go over some of the new features that are available in SOLIDWORKS with the 2019 release. If you went to one of our launch events, we're going to go over some of the same features we saw there. I'm going to concentrate on some of the newer modeling features that are available sort of within the standard package. At the end, I just want to talk about some of the improvements to some of the add-ons as well that are available, some of the other improvements that we can't really demonstrate that well in a webinar. So I'm just going to run over some features now. That'll take us for about half an hour. Then I'm going to just have a quick chat about SOLIDWORKS generally, other improvements, and I'll open it up to questions at that time. So what we have here is just the handle, a trigger assembly used to control a recreational vehicle. We're sort of getting into an era where between improved molding and machining and additive manufacturing processes are allowing us to create ever more complex surfaces, and we may want to do that either for sort of marketing or industrial design purposes, ergonomic purposes, or potentially even like an NVH purpose. We may want to add a texture to a surface. Historically in SOLIDWORKS we've been able to indicate textures visually, but actually modeling them in 3D has been a challenge. However, there's a new functionality that will allow us to do that. So if I zoom in on my handle here, just at this turquoise grip part, I'm going to open up this part. I can, as I've done previously, apply a texture appearance to that. I'll just do that very quickly. I'm going to grab this knurled appearance, going to put that on this front here. Just going to clean it up a little, just so it's appearing properly. Give me 1 second here. I'll map that, just do a projection, improve the size. So I've got sort of a diamond knurled pattern on this part. At the moment, that's just applied as an appearance. It's looking good, but it's not that useful if we actually, it's not that useful in terms of manufacturing data or telling us what the part will actually look like. What I now have the ability to do in SOLIDWORKS 2019, if I expand out my solid bodies list here, or I can have it listed as a separate feature, I've got the option of 3D texture. So I'm selecting on my body, I've got this option 3D texture. I'm going to select on that. It's giving me the option to select some of the 3D, some of the appearances that have been set. I've only got one in this case, so I'll just grab that. And what I can do now is I can play around with some of these settings. So it has a bit of a think, and I'll turn that to shaded but without edges, so it's a bit clearer. Come on. What's happening here, if I hit go there, what I can see now is that that texture has been converted into 3D geometry. There's some algorithms behind it. I'm not entirely sure how the maths all works, but it's interpreted the coloring of that knurling texture that we've applied, interpreted it into a piece of 3D geometry. It's then converted the part into a mesh body, and it's applied sort of a change to that geometry based on the pattern that we've applied. In terms of this, in terms of how it's reading there, it can do this with, there's a variety of different image formats that it can read in. However, there's going to be a limit in terms of the complexity of the image that's being read in, if there's big changes. It also needs to be a monochrome, so black and white image. It's then able to interpret the depth to which it should be applying this finish based on sort of the color, whether it's black or white. You can invert the selection as well if I go back here. Excuse me. I can go back, I can change this, invert what I've got. It has a bit of a think. And I get the inversion of that, so it's now going inwards. Okay, so that's it's converting it to a mesh body, so it can be a little bit fiddly in terms of, if we zoom in, we can see there's a whole bunch of facets in place here. Oops. You can see I've got a bunch of facets in place, so a bunch of very small planar surfaces. Might be difficult if you want to bring this part into a machining program, for instance. It might bring it in, but then not be able to interpret it. Just something to be aware of if you want to go ahead and use this functionality. I think it should be okay with additive manufacturing. Nonetheless, and it is giving you that geometry. You just may want to consider sort of your overall production process and how this function would impact it if you wanted to use it. Nonetheless, it gives us that 3D geometry, but the more realistic to production part. Okay, so I'm going to save that, close this part down. Going to go back to our assembly. Yes, I will rebuild the assembly. Going to carry on. Something we're now able to do, and it's a minor tweak but a useful one, I'm just going to hide this body. I can see here within my trigger mechanism, I've got a cable running down here, and I'll just hide my grip as well. So I can see there's a bit of interference between this cable running from the button at the top and my front wall. I could put a chamfer on that to create a bit of clearance. However, I'd start to get some not quite right wall thicknesses around this area. I'd be thinning it off. We might sort of see the mold isn't filling completely. And when I think about it, I only need the fillet to sort of be around this area, not all the way along this edge. What I can do now, and I'll just go in and edit this part. If I go into chamfer, if I select the offset face option, and what I'm about to demonstrate is only available through the offset face option, I'll make it a 1 mil chamfer, drop it onto this edge here. So I've got that running all the way around, as it would do in 2018 or previous. I've now got this partial edge parameter option. So if I turn that on, I get a pair of handles, a green and a purple, at the end of my chamfer. I can drag that around like so to determine on what proportion of the edge the chamfer is being applied. I've just dragged it manually myself just to get it into place, but you can see here I can control the distance offset that I've got in place there, so I could set that to 20 like so, and 25 like so. I can also do that as a percentage or to a reference point, so I could have it go to a specific point on my edge. In this way, it's a minor thing, but it just gives you that much more control over chamfers and fillets as well. This is available within fillets in order to get the geometry you need, but only in the area in which you need it. It's a small change, but one that's going to have like a big impact if you find that if you need to refine your fillets and find that can be quite difficult at times. Okay. Do a quick rebuild here. One final thing I can do in this assembly, I've got a button in here. Quite often we'll find parts like these, COTS parts. We'll get a model off the manufacturer. It might be sort of like an STL or something, and that's all fine, but it's something with a few holes in it, and we may need to clean those up for whatever reason. We may need to generate 3D geometry from a given STL file. However, it may be a bit messy when it comes from the manufacturer. If I open this part up here, in order to facilitate that, I can now do a bit of a cleanup on surface bodies. If I select this edge here, I can right click. I've got this option of delete hole. So this has picked up that it's a surface body and there's a hole in place. I can delete that hole, and I can see that it's patched over that area there. So if I do get one of these STLs that's come from a manufacturer or from a scan or somewhere, I do have sort of these options to go through and try and clean it up, make it a bit nicer, maybe something that's either a bit more indicative of what we actually want in our part, or just something that has been cleaned up for some 3D modeling onwards. Okay, that's what we're going to do. That's what we've got for this part. Just close, yeah, I'll change that, save that, why not? Yes. Okay, so I've got my assembly all done. Close that down. Yeah, we'll save that, why not? Okay. So in building something like a multi-body part, typically a weldment, it's quite easy to design or model that part such that there's interference in place that we wouldn't actually want in practice. Within SOLIDWORKS assemblies, we've long had the ability to do an interference detection on our assemblies to see if there's any interference between the bodies of the parts that are brought in. However, if we wanted to do the same on a multi-body part, say a weldment, there's been a workaround in that you can bring that weldment part into an assembly, run interference detection, and it'll pick up if there's any interferences within that part. However, that's a bit of a workaround. It works fine, but it's a bit laborious. What we are very able to do now in 2019 is, if I have my weldment part, if I go to evaluate, I've now, within a part file, I've got the option to run interference detection. So I'm going to run that now, calculate, and I can see just within this part, I'm picking up some interference. I'm able to now go and clean that up in the model if I wish to, such that I could fix this up, get something that's much more producible, and it's a much more streamlined process from now on. I don't have to bring that part into an assembly, check it that way, and then go back into the part and edit it. It's a small change, but again, one that if you're dealing with a lot of weldments, just kind of streamlines that process. You'll see a lot of cumulative improvements. Okay, we'll close that down. Assemblies. So assemblies have long had the ability to show an exploded view, and that's been quite useful on drawings, but also there's the ability to record. There's long been the ability to record an animation of that explode. So rather than just having a static drawing that you might be showing to people on the shop floor, you could potentially have a screen, have that exploded view shown animated as to give them a much better indication of how a given product is going to be assembled. The downside of that historically has been that the explode view in SOLIDWORKS has been a bit of a pain to edit. It's been doable, but it hasn't been the nicest user interface. If I go back to my, if I now go in 2019 to my exploded view, I'm going to explode this, expand this out. I can see now, and I can see it here, just in the regular configuration tree, I've actually got a rollback wheel now, rollback bar rather, in place. So I can turn my explode states on and off. If I go in and edit my exploded view, I'm actually much more like a traditional part feature tree or an assembly tree. I'm actually able to go in and control what's going on here. I can control the order in which my explodes are happening. I can control, and I can go and add steps at a previous point. If I've just got a static explode like so, that's not too useful. But if I am doing something like an animated explode that I then want to export as a video, that order becomes quite important. So if I get in a situation like here, I don't know if you saw it, so I'll run that again. But I can kind of see that my end cap here is coming out in my as an exploded state before the bolts are pulled out. That's not how this part would be assembled in practice, disassembled in practice. So I'd want to go and correct that. Previously, that's been a very laborious process. However, now I can simply drag the screw step. I can just drag it up as I would do in any other tree, like so, before it's such that it's happening before that end cap explodes step. And now, if I'll collapse this, if I now animate that explode, I can see that it's now exploding in the correct order. Similarly, if I want to go in and I want to add some steps here, I no longer have to simply add them at the end. I could roll back like so, and I could add in an explode step here. I'm going to expand out these washers. Just do a box select there. I've got auto spacing on, so I can just space them out like so. So I can see my chain has been, my new explode state, exploding these out, has been added there. My new explode step has been added there. I can now roll forward and turn on the subsequent steps. So I end up with a much more flexible and much more editable exploded view, allowing me, when I do my animated explosion, I'm now able to I'm now able to ensure that that's in a good state, that I can save it out as a video that can then be used for training or production purposes. Okay, going to close that down. Within assemblies, as I'm sure you're aware, you start adding components. They all typically have, at least 3 mates for the most part. You start to get, relatively simple assembly starts to become quite complex, and therefore any kind of troubleshooting of that assembly will also become quite complex. There's a little bit of functionality that's been added in here just to make that a little bit more straightforward. So if I open up this part, which we'll find has a bunch of errors in it, thank you. Someone saved it in a state with a bunch of errors, which is not ideal, but nonetheless, there we are. I can see, all right, I've got a bunch of red marks against a number of parts. I've got some khaki against some others. It's easy enough. It's straightforward enough to go through and sort out what all these mates are and what all the errors might be. However, it's always a bit laborious to be working through either just the parts individually or this list of mates. What I can do now is I can group my mates. So I can right click here. I've got the option of group mates, and I could go by status. So rather than simply having my mates in one big list, I can now see that they're grouped by those mates that are solved okay. I'll just expand this out a bit. The mates that have errors in them, and the mates that are overdefined. That's going to make it much easier to troubleshoot this assembly, go through and fix these mates up. So I can see, all right, I've got my perpendicular here. I'm just going to go through and edit that. I can see, all right, I've got a missing plane. Just fix this face up. Make sure I grab it. Yep, thank you. Yep. Yeah, I will replace the other missing reference. Might help. Okay, so I can now see, if I look back at my mates again, I've got a collapsible folders, so I've collapsed my solved mates. I can see now I've now got 102 mates solved. Those two, now that I've fixed them, have moved to that folder. I can now only see my overdefined. So it's overdefined mates. So it's much easier to go through and edit what I'm seeing here. So I can see, all right, I've got a distance mate here, and I've got a coincident mate. They're kind of on the same face, so that's not ideal. I'll delete out this distance mate. Actually, I'll suppress it. It's probably a bit cleverer. Okay, and now I can see everything's working. I've got all my mates are now solved and working. So that's all good. Okay, traditionally as well, if you're putting in a lot of bolts or nuts or washers, anything that has no sort of definitive or defined orientation rotationally, it's a good idea to lock the rotation of that part. It ensures that we don't have dashes against the part in our tree, so we can see that it's all fully constrained. Makes it a bit easier to go through and do the rebuilds as well if everything's fully constrained. It's also just a nicer way to model. So that ability to lock rotations is sort of a very neat way to model. However, in practice, I'm sure we've all found that you're modeling and modeling and modeling, just sort of hitting that lock rotation checkbox within your concentric mate. Very easy to forget to do that as you're putting parts in place. So you can end up with parts that are sort of not properly constrained as you may want them to be, just in the course of modeling. What you're now able to do, if I right-click here on my mate group, just on the mate group that's always been there, I've now got this option of lock concentric rotation. What that will do is any part that is not fully constrained but has a concentric mate on it, it will lock that concentric rotation. So if we have gone through and set up all our bolts and forgotten to lock that rotation, we can go and turn that on. So I can do that right now. I can see I've now got some of my mates, my concentric mates have had that applied. Others, for parts that are constrained otherwise, it hasn't applied them. I've also got the option, I can right click and I can go unlock concentric rotation. That it doesn't undo the lock concentric rotation I've done previously. Any locked concentric rotation within that mate group, it'll unlock those, regardless of how they've been set. Of course, even that's a bit of clicking, and quite often the parts that we want to define this way, nuts, bolts, washers, etc., they're typically defined as toolbox parts. So to sort of bypass this need completely, I've also now got an option. If I go options, whole wizard toolbox, there's yes, I've got this option now, toolbox mates, lock rotation of new concentric mates to toolbox components. So every time you bring in a toolbox component and apply a concentric mate to it, it picks up that that's a toolbox component and locks that concentric mate. Again, just makes that whole assembly process a bit more streamlined. Okay, so I'm going to close that now. All right, I'm going to step away from SOLIDWORKS for a quick minute. I just want to talk about eDrawings because there's a new functionality within eDrawings Pro that's quite nice. So I'm going to open up eDrawings Professional here. I'm going to open, excuse me, this assembly here. So I've got my assembly opening in eDrawings as usual. Typically, if I wanted to send this SOLIDWORKS file or an eDrawings file to someone, that person would need some kind of viewing software at the other end just to see a CAD file. With eDrawings Pro, I've now got the option. I can save this part. I can save this as an eDrawing web HTML file. I'm just going to drop this on my desktop. What this does, what this creates is a sort of a very light CAD file just for viewing purposes. That, and you can see I've got a Chrome logo against it because, let's open that up. Fingers crossed. This will open just in a web browser. So I can, if I have eDrawings Pro, I can save it in this format, send this to pretty much anyone in the world, as long as, if I'm sending it, I'm typically sending it online, which means they have a web browser. That means they'll be able to open it. I don't need any kind of viewing software for this particular file type. I can just save it as a web HTML file. They'll be able to open it up in a browser. And there's a little bit of limited evaluation capacity in here. I could, for instance, put a section on that, have a look through it. I can do a quick explode, not the explode that you would set up in an explode view, just an explosion like so. Just kind of a radial explosion. I can see different configurations as well of that part. The one thing I can't do that everybody asks about is there is no measurement tool within eDrawings, so you'd have to provide major dimensions. It's more of like a high-level review capacity, sort of for concepts. If you want to do detail review, it's certainly advantageous, but it's not going to let you be the only software you can use for such a thing. So I can do that. One last little bit of functionality that I want to go over is there's a new functionality called structure system. This is a new way of doing weldments. So if I've got a simple part like this, let's just review it. I've just got a couple of hexagonal surface bodies in place. This is kind of a conceptual model of a large framework that's actually going to be used for a telescope. It's just been built up out of a couple of hexagonal surface extrusions just to give sort of a rough placeholder part. It's the sort of thing that if I actually wanted to build the weldment from it, I'd typically have to go back and I'd have to go back and sort of build it from scratch. However, I've now got an option called structure system, which I can do here, which can pick up any of these edges and use it as sort of the path for a weldment. So I can go structure system. I'm going to start with a primary member like so. I'm just going to do it's asking me to select where my primary members are. I'm just going to do a great big box select like so. I'm going to choose my profile. I'm going to use 80 by 80 square tube. It's a bit small, but nonetheless it demonstrates the principle. And I can see I've now got a whole bunch of weldment members in place there. I can then go through and do things like add secondary members. What these do is I need to determine a plane on which my secondary members sit. So I'm going to grab my top plane and this plane at the top up here. I'm going to select the members between which those secondary members run. So I'm going to grab, I want to link up like so. I can see I've grabbed multiple planes, so I'm putting that in at the top and bottom. If I can grab it like so. So I've now got a completed structure together. With some simple selections from that very basic geometry that was already in place, I can hit OK now. I'm happy with my members. I can exit out of this, and it's going to prompt me to go and clarify my end conditions. So I can grab this. Set all my weldment corner treatments. So I'm going to grab that one like so. That one, I'll do the same. So on and so forth. Go in and set all that information. I'll just do those two for demonstration purposes. And now I've got my weldment structure in place. From some very simple selections and tweaking some settings, I can generate quite a complex weldment structure just from some basic geometry that I might develop in something like a placeholder file. Okay, we're sort of getting towards the end of the half hour, so I just want to discuss some other capabilities. The big thing within SOLIDWORKS 2019 is actually that there is a lot of improvement in terms of the performance, especially around large assemblies. We're sort of at the point where sort of certain large assemblies that you would have to be editing in large assembly mode in order to be able to manipulate them without too much frame dropping. You're now able to just edit in the regular mode, and they move quite smoothly. Having said that, the reason that's capable, the reason that capability is able to be done is that SOLIDWORKS is doing a lot more work on the graphics card of your machine. Therefore, it's very important to have a graphics card that's actually supported. If you want to use that functionality, I need to go into performance. There's an option down here, enhanced graphics performance. Turn that on if you've got a supported graphics card. And you'll see a lot better functionality. However, if you have an unsupported graphics card, just so happens that this demonstration machine that's the case for this machine, you may find that grayed out or not available. In addition to, so that's sort of one of the bigger changes. There's a bit of extra integration with regards to PDM as well. Simulation, there's been improvements to the topology study functionality that was introduced in 2018. Now if you're doing a topology study, you have the ability to set a limit stress rather than have to just tweak some of the settings previously were a little bit limited and relied on you setting a percentage of mass reduction. You can now play around with a limit stress, makes it a much more sort of relevant tool to be using. What else? I guess generally speaking, we often come out of our launch events, and when talking about the improvements to 2019, we've often found that at those events, people come up to us and ask us, why is there a certain functionality that they've never gotten, that SOLIDWORKS or Dassault systems have never gotten around to introducing? That suggestion for that feature needs to come from the users. It can't come from us, the reseller, and there is general industry consultation. However, for specific and detailed features, it needs to come from the users. If you want to suggest a feature, if there's something you've been looking for a long, long time and just been waiting for SOLIDWORKS to introduce, let us know. We can send you what's called an enhancement request. That'll get forwarded on to SolidWorks. We can't guarantee that that'll be implemented in the next release. However, the more data there is on what customers actually need, the better the product's going to be, and the better it's going. And if you suggest one of those enhancements, the more likely it's going to suit your particular needs. Similarly, in terms of just sort of improvements of bugs across the 2018 release, so from 2018 SP0 to SP5, I think there were 380 software performance reports were closed, so they addressed 380 of sort of some of the bug reports SolidWorks had gotten. Between SP5 and 2019 SP0, so the first release that was made available to the public, there were an extra 960. So from point to point in the release process from 2018 to 2019, there were about, was that 1,350 or so? I think that's right. Bug reports that were closed off. So if you've had one of those, you should have got an email from SolidWorks telling you it was resolved. If not, still to come. I know there's some other sort of larger structural changes in the works for future releases. Conversely, if you are seeing a bug or something within SolidWorks, please contact us. We can raise one of those SPRs or potentially see if there's a workaround for you. If you don't report it to us, it's not going to get fixed, or it may be a lower priority for SolidWorks. So please make use of your support that you're paying for to report those processes to us. Can't guarantee when it'll be fixed, but if you don't tell us, it won't be fixed at all.